We need to determine the equation of a parabola, which is having its focus at the origin, and equation of the directrix given by y equals to 2. Let us begin. We'll try to understand the problem graphically first. For this, what we'll do, we'll first consider our coordinate axis. So it's given here that the focus of the parabola is at the origin. So that means this is going to be the origin point of origin. O is going to be the focus of the parabola. So let's name it O with the coordinates 0, 0. Then we have to represent the equation of the directrix here. So the equation is given by y equals to 2, and we know that any line having the equation of the form y equals to 2 is going to be a straight line that's parallel to the x-axis. So let's say this is the point y equals to 2, and the line is going to pass through this particular point, and it's going to be parallel to the x-axis. So here we have the straight line with the equation y equals to 2, and it's going to be parallel to the x-axis. Now our goal will be to determine the equation of the parabola. To begin with, we'll consider a point P with the coordinates h, k. So here P is going to be the locus of the parabola, and the locus of the parabola is such that if we join point P and point O, and also if we drop a perpendicular from point P on the directrix line such that it meets the directrix lines at F, then by definition PO must be equals to PM. So we'll begin from here. So by definition PO must be equals to PM. Now we can easily find out PO because here we have the coordinates of the endpoints, and you can use the distance formula to obtain the length of PO. All we have to do is take the square root. Underneath the square root, we take the difference of the x coordinate, square it, and add it to the difference of the y coordinate and square that value as well. So this will be equals to perpendicular length PM. Now there is a standard formula for obtaining the perpendicular length PM. Let's go through that formula. So here we need to have a point first with the coordinates given to us x1, y1, and we have a straight line which is having the equation ax plus by plus c equals to 0. Then dropping a perpendicular from point P onto the straight line gives us PM. So here PM is going to be the perpendicular distance, and that's given by the absolute value of ax1 plus by1 plus c divided by the square root of a squared plus b squared. So we're going to use this formula here. All we have to do is take the absolute value. Now underneath inside the absolute value, we have to consider a ratio. We'll first begin by considering the straight line. So here we have the equation of the directrix y equals to 2, but we have to rewrite in the standard form ax plus by plus c equals to 0. That means our straight line is now going to have the equation 0 times x, because there is no x present here, added to y. So y can be written as 1 multiplied to y, and we transpose the 2 from the right hand side to the left hand side to get negative 2. So we have the equation of the directrix written in its standard form. So it will be 0 times x plus 1 times y minus 2 equals to 0. So if we use the formula, then we'll have to start with the coefficient of x of the straight line. So that's 0. 0 will get multiplied with the x coordinate of point P. So that's h. So we have 0 times h added to. Now we'll consider the coefficient of y. So that's 1. 1 gets multiplied to the y coordinate of point P. So that's k. Then we have the constant term added to it, so that's negative 2, divided by the square root of, so we'll have to take the sum of the squares of the coefficient of the straight x and y of the straight line. So that means we have 0 squared added to 1 squared. Let's further simplify. That's going to give us the square root of h squared plus k squared equals to the absolute value of k minus 2 divided by 1. Now we'll square both sides to get h squared plus k squared equals to k minus 2 whole squared. Now we will expand k minus 2 whole squared. So that's going to give us k squared minus 4k plus 4. So we can cancel out k squared from both sides. That leaves us with h squared equals to, so we'll take negative 4 as the common factor. So negative 4 gets multiplied to k minus 1. So we're almost done. Finally, what we'll have to do, replace the value of h with x and the value of k with y. Now since we have h on the left hand side, so we'll get x squared equals to negative 4 multiplied to y minus 1. So this is going to be the required equation of the parabola obtained from the given two conditions, that the focus of the parabola will be at the origin and the directrix is given by the equation y equals to 2. And also Here the equation is having the standard form, and this is going to be a downward facing parabola. You can use a standard graphing calculator to sketch the graph of the given parabola.